Welcome to the Thermal Protection System Challenge. Today you guys are going to be learning all about how to design a thermal protection system for a spacecraft. In 1969, man walked on the moon for the first time. The challenge was not necessarily just getting man to the moon, but also getting them back safely. In order to do this, their spacecraft had to have a thermal protection system. Anything that comes through the atmosphere experiences an incredible amount of friction, which causes heat. So NASA had to design a thermal protection system. We see what happens to objects that don't have this system when you look up in the night sky and you see a shooting star. It burns up in the atmosphere. We don't want that to happen to our astronauts, so they had to design a thermal protection system. Our next step is to send men to Mars, and women, and we will also need a thermal protection system not only to get them back to Earth, but also to help them land on Mars as well. Because of NASA needs engineers who can design thermal protection systems. Those engineers have to have a strong understanding of the concepts of heat transfer that we've been studying in class. Here you see the current system, or what was the current system when we used the space shuttle. It was thermal protection tiles. This is me standing underneath the space shuttle Atlantis. The bottom of the shuttle is covered in these tiles. As you can see, these are scorched. This shuttle had just landed a few days before this picture was taken. They were damaged, they were scorched from that incredible friction as it came back into the atmosphere. In 2003, the Space Shuttle Columbia had a problem with their thermal protection system. It was damaged during the launch of the space shuttle a week and a half earlier. As they came back into the atmosphere, the incredible heat built up, and where there had been a damage done to the thermal protection system, that heat weakened it even more and caused it to what's called zipper or unfurl. And unfortunately, the entire crew was lost because of a failure in the thermal protection system. You use thermal protection systems every day. You use a potholder or a thermos bottle, or a fireman uses a special coat. These are all doing the same job that a thermal protection system on a spacecraft does. It protects you from the heat. So there are two types of thermal protection systems. The first one, that was used by the space shuttle, collects that heat and then radiates it back out. Earlier systems, which were used by Apollo and which were equally effective, allowed small bits of the protection system to burn up and fly away, and then there was another layer. So it was multiple layers protecting the spaceship. The key concepts for this lab are going to be conduction, convection, and radiation. At every step in the design process, you must consider these. Groups that do not think about these three concepts will not have successful thermal protection systems. So we have to think about conduction. What heat is actually touching? How is the heat being transferred through actual touching? What radiation is going on? And what convection or movement of air is happening? So here is the actual challenge. You are going to be given a wooden dowel rod. Hot glued to the end of that dowel rod is going to be a screw with a nut at the end of it. Your job will be to keep the glue from melting. The glue represents the crew inside the spacecraft. Once that glue melts, your system has failed. All thermal protection systems will fail at some point. The challenge for you is to make yours last as long as possible. You will be given different materials to create your thermal protection system. Those materials can only live in this area. That's the only place you can put them. You cannot attach anything to the wooden dowel, and it cannot go further back than the hot glue. You have to imagine an imaginary line that goes through that glue, and nothing can go beyond that. So mainly your main resource is going to be tin foil. You will use that tin foil out in this area to protect the hot glue. When I test these, I will take my blowtorch and I will face it at the end of the screw. This will heat up the screw, the heat will travel, etc., etc. Your job is to protect that hot glue. There are a few requirements. You may not use any materials other than what I give you. That means no tape. You must work as a team. Everything that you put on there has to stay attached using nothing but the bolt at the end of the nut. You can only use the materials that I give you, and you cannot go beyond the hot glue, meaning you can't attach anything to the wooden stick or go back that direction. The timeline for the project is as follows. Today you're going to learn the requirements and ask any questions that you may have. Tomorrow you're going to design. You're going to come up with detailed sketches. And what I would do is have each individual person in your group come up with a sketch, come up with a design. Then you share those and choose the one that you feel as a group will be the best. Friday is going to be your build day. You only get one day to build. And then Monday is the day we've all been waiting for, and that is blowtorch day. So that pretty much wraps up the thermal protection system challenge. If you have any questions, now is your chance. This video is going to be posted on my website, so if you have further questions or need clarification, feel free to go back and look up this video. Good luck!